Hello Algebra 1 class, this is the video for lesson 39. We're going to talk about difference of two squares and a rhombus. Now we did difference of two squares last year, so this shouldn't be so new. The new thing about this is we're going to solve equations by factoring quadratic equations by using the difference of two squares method. So just a little bit of vocabulary here. I don't know if you remember this or if we've even talked about this. Hold on one sec till I get my pencil out. If you have negative 2x minus 3y, the conjugate of it is negative 2x plus 3y. When you're doing a conjugate of a binomial, you keep the first sign the same, and the only difference is the second signs of the second term are opposite. That's what makes it a conjugate. Like this one. Hold on a second, let me just fix this up here a little bit. I have my weight out here. Okay, there we go. Now this is minus. If we have 3x plus 4, the conjugate of 3x plus 4 is 3x minus 4. Now the important thing about a conjugate is when you multiply two conjugates together, their product does not have a middle term. So when we go to do FOIL, let's do FOIL on this one. Remember, we do the first, we would get positive 4x squared. The outer would be negative 6xy. The inner would be positive 6xy. And our last would be negative 9y squared. Every time you multiply a binomial by its conjugate, the middle terms add out, and you get 4x squared on this particular case, minus 9y squared. And what you get is what we call a difference of two squares. This is the difference. I'm not writing too neatly here today. Difference of two squares. Now, of course, when we factor a difference of two squares, we're going to get a pair of conjugates back. Let's try this one if we do FOIL. The first would be 9x squared. The outer would be minus, remember your outer, minus 12x. And your inner would be positive 12x. And your last would be minus 16. Here again, the outer and the inner always add out, and we're left with the difference of two squares. Now, let's talk about why it's called a difference of two squares. If you look at this, you have 9x squared, and you can see that 9 is a perfect square because 3 times 3 gives you 9. So that's why it's called a perfect square, and x times x gives you x squared. And 16 is also a perfect square, and we have to have the negative sign. That's what it means by a difference of two squares. Now, whenever you're going to factor, we could go the other direction with this. If we were told to factor this, we would make two sets of parentheses, like such, and we would put in the square root of the first term, there and there, and the square root of the last term, here and here, and then we just make it the conjugate, plus and minus, because we know there's no middle term. Okay, let's try a problem now. We're really jumping ahead here. We're going to solve this equation. Now remember the last video I talked about how this is a quadratic equation. Whenever you have an highest exponent of a 2, right away you should think, quadratic equation, I need to set this equal to 0. So that's what is done. It's already done for you. If it's not done, if you had something that wasn't set equal to 0, you would need to get everything on one side of the equal sign. And then quadratic equations, for right now, the way we're going to solve them is by factoring. So let's just try this one. You can see, if I look at this, I say, 4 is a perfect square and 9 is a perfect square. So this is a difference of two squares. So I should solve this by factoring with conjugates. So you just go make your two sets of parentheses. Whoops. Yep, it's still equal to 0. And you'd say, what times what gives me 4x squared? And that's going to be 2x. You have to be able to identify that it's a difference of two squares. And then you say, what times what gives me 9? That would be 3 and 3. These are actually very easy to factor compared to some of the other ones that you had in the last lesson. And there we go. Now we have two factors. When you multiply them together, you get 0. So one of these factors has to be 0 in order for this whole thing to be 0. Like if I have 3 times something has to give me 0, well, that something has to be 0. So we're doing the same thing. One of these two factors have to equal 0, so we have to figure out what it would be. What would make this one 0 and what would make this one 0. So what we do is we set them each equal to 0. 2x plus 3 equals 0, and 2x minus 3 equals 0. So after you factor, even if it's not a difference of two squares, if it's just a trinomial, you set each factor equal to 0. And then you solve. So we're going to get 2x equals negative 3. And then we'll divide both sides by 2. And we get x equals negative 3 halves. That's one solution to this equation. And then we get 2x equals 3. Divide both sides by 2, and we get x equals 3 halves. These are the two x values that when you put it back in, if I put it back up here and squared it, multiplied it by 4, then subtracted 9, I would get 0. These are called the roots or solutions to the quadratic equation. If we were to graph a quadratic equation, it would be a parallelogram. Remember our parallelogram friend here? I mean, not parallelogram, a parabola. My pencil's going the wrong ways today for some reason. It's out of control. These solutions would be where it crosses the x-axis. I don't know why I'm writing crooked today, but it would be the places where it crosses the x-axis. That's also the solution. If you could graph this and find the solution to the quadratic equation just by looking to see where it crosses the x-axis. Okay, we'll get into that later when you're in advanced math. Okay, let's try one more of these and then we'll go under the rhombus. Okay, you look at it. It says solve by factoring. So what you have to do is set it equal to 0 because it's quadratic here with that 2. You're going to begin by factoring. Before you factor, you should really look for, is there any common monomial factor? Is there anything I can take out? Always look for that first, but there isn't. I see this is a perfect square. That would be 9m for this one and 5 for this one. They're perfect squares, and it's a difference. You can't do the sum of two squares. You have to do difference. So here we go. So we'd say 9m, and then it would be 5 and 5, and then one has to be plus, one has to be minus. It doesn't matter which is which. And we set each of these factors equal to 0. So we get 9m plus 5 equals 0, and 9m minus 5 equals 0. 9m, if we subtract 5, and we get m equals negative 5/9, and we solve this side, 9m equals 5, m equals 5/9. And those are the two solutions that would make this true. And also if you graph this, it would be a parabola crossing the x-axis at negative 5/9 and positive 5/9. Okay, hopefully that worked for you. Let's go on to rhombuses for a change of pace. Okay. Now, a couple lessons ago, and I actually put on here a video of parallelograms just in case we rushed it too much last time. But here's the things about the properties of a parallelogram. The pairs of parallel sides are equal. The angles opposite each other are equal. The sum of the adjacent angles are not equal. That should be add up to 180. Whoops. Hold on a second. Let's erase that. Okay, they don't add up to 180. They're not equal. They add up to 180. All right, and the diagonals bisect each other. Those are the characteristics of a parallelogram. Now, what a rhombus is, it's a parallelogram. So all these properties of a parallelogram are true, but their four sides are equal. It's kind of like a square. A square is a rhombus. A square is a parallelogram. But most of the time when we draw rhombuses, or rhombi, I don't know the plural of that, you just tilt it. That looks like that. It's like a tilted square. But it doesn't have to be. Squares are also rhombuses. You can tell a rhombus has all these qualities of a parallelogram, but it has 4 equal sides. The diagonals of a rhombus bisect the angles of the rhombus. So that means, here's the diagonals. It's going to make this angle equal to this angle, and this one equal to this one, and this one equal to this one, etc. And another property of a rhombus that's different than a parallelogram are the diagonals form perpendicular bisectors. That means they form a right angle, and these are equal both ways. Okay, let's try a rather complicated problem. This is going to be like your homework problems. The practice problem in your book is very similar to this one. Okay, it says DEFG is a rhombus. The measure of the reflex angle. Now, what a reflex angle is, it's this angle that's outside of the quadrilateral, is 280. We need to find A, X, B, K, and C. So we're going to start out by finding the sum of X and A here. If we know that all of this is 280 and a circle is 360, we're just going to subtract 280 from 360, and we're going to get that the sum, we're going to get that angle X plus, I'll just leave it like that. The degree of X plus the degree of A equals, it would be 90 that are left. 80. 80 degrees. Since angle X and angle A, according to the properties of a rhombus, are equal, that means they share the 80, so we would have angle X, so we would say X equals 40 and A equals 40 degrees. Okay, we're getting somewhere. Okay, now we need to find out B, K, and C. And there's more than one way to do these. But do you remember the properties of a parallelogram? That the adjacent angles, that means this angle right here and this angle right here, these two angles have to add up to 180. We already figured out that X plus A equals 80, so that tells us that we would have, if they add up to 180 together, that means K plus B degrees equals 100. Because 80 plus 100 would give us if we added those together, this angle and this angle would give us 180. So that tells us, since K and B are equal, they split this 100 evenly. So we're going to get K equals 50 and B equals 50. So we did this, 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 and this. Now all we need is angle C, and that's easy because if we know it's a rhombus, we know that it forms a perpendicular. They're perpendicular bisectors, and when two lines are perpendicular, it means that their degree measure is 90. So C equals 90 degrees. So hopefully you got all that. Please email me if you have a specific question you want answered, some problem you don't get, and I still have your index cards to go through to see what specific help you need. So that is it for lesson 39. If I can stop the video, that is. It's trapped here.